Hey guys, today we are talking specifically about arithmetic sequences. So an arithmetic sequence is the difference between consecutive terms is constant. And so that means we are adding a different value every time. So we refer to that as the common difference, and we use D to represent the common difference. So an arithmetic sequence would look something like this: 5, 11, 17, 23, 29. So you'll notice we are adding 6 every time here. So yes, this is an arithmetic sequence, and D would be 6. If you're not sure, you can always subtract backwards: 29 minus 23, 23 minus 17. And so on. Would example 2 also be an arithmetic sequence? If you're not sure, subtract backwards. 10 minus 6 is 4. 6 minus 4 is, or 6 minus 2 is 4. 2 minus 0 is 2. That's not good. 0 minus negative 2 is 2. And then we jump back to 4s here. So this one's a no, because it does not have a common difference. Here's our rule for arithmetic sequences. A sub n equals A sub 1 plus D times n minus 1. We said D is our common difference. And we know that n is our term number. A sub n is our nth term. Remember, we called that our term value last time. And so then A sub 1 is our first term. So basically we take our first term plus the common difference times the term number minus 1. So example 3 says, write a rule for the nth term of the sequence. So a couple key pieces. We need to know the first term, and we need to know the common difference. So first term's pretty obvious, it's 3. And then if you look at the common difference, is what we're adding every time. We're adding 4 every time. So we use our rule then. A sub n is equal to first term plus common difference times n minus 1. So that is the arithmetic sequence form. We typically go ahead and multiply it out. So we get rid of those parentheses. So 3 plus 4n minus 4, or A sub n equals 4n minus 1. Okay, write a rule for the nth term of the sequence, then find A sub 12, or the 12th term. Well, A sub 1 is 32. Our common difference, what are we adding every time? Looks like we are adding 15 every time. So A sub n is equal to 32 plus 15 times n minus 1. Go ahead and multiply that out, simplify it. So 15 n minus 15, A sub n is equal to 15 n plus 17. There's our rule. Now we want the 12th term, so A sub 12. That means anywhere we see an n, we're replacing it with a 12. So 15 times 12 plus 17. So A sub 12, we plug that in the calculator, we get 197. All right, one term of an arithmetic sequence is A sub 8 equals 50. The common difference is 0.25. Write a rule for the nth term. Okay, so I'm going to go back to writing this out. So there's just our basic rule. We know some information. We know the common difference is 0.25. We know a sub 8 is 50. So a sub 8 is 50, which means that n would be 8 in this case. From there, that would mean that our only unknown here would be a sub 1. So we could solve for a sub 1 at this point to be able to write that rule. So a sub n, we're going to use a sub 8 here. That would be 50 is equal to, we don't know our first term. We know our common difference is 0.25. We know our n is 8. So then I have 50 equals a sub 1 plus 0.25 times 7. So I get 50 equals a sub 1 plus 1.75 minus 1.75 on both sides. So a sub 1 is equal to 48.25. Okay, so then a sub n, writing our rule, is 48.25 plus 0.25 times n minus 1. Go ahead and distribute that 0.25, get rid of those parentheses. So we get a sub n is equal to 0.25 n plus 48 when we simplify that whole thing. So there is our rule. So we had to find the first term and then go back and plug it in. Okay, here's another example for us. It says write a rule for the nth term of an arithmetic sequence where a sub 5 is 10 and a sub 30 is 110. And then B, write the value of n for which a sub n equals negative 2. So, we don't have first term here, we don't have the common difference here, but we do have two different values. So the way this is going to help us is that perhaps we can use a system of equations. So if we know that a sub 30 is 110, we can plug in 110 for our term value is equal to a sub 1 plus your difference times 30 minus 1. And then we could use 10 is equal to a sub 1 plus your difference times 5 minus 1. Let's simplify that a little more. That 30 minus 1, 5 minus 1 we can simplify. So 110 is equal to a sub 1 plus 29d. And then 10 is equal to a sub 1 plus 4d. Well, we can, since we have a sub 1, if we just combine these system of equations by subtracting, we get 100 equals a sub 1 minus a sub 1 is gone. 29 minus 4 is 25 times d. So divide by 25 on both sides. So d then would equal 4. We're still not done because we still don't know what a sub 1 is. So I'm going to use the smaller value here of 10 is equal to a sub 1 plus, and I'm going to use this simplified equation, 4 times d, so 4 times 4. So then I get 10 is equal to a sub 1 plus 16. I'm going to subtract 16 from both sides. So a sub 1 equals negative 6. So then I get a sub n equals a sub 1 plus difference times n minus 1. So a sub n equals negative 6 plus 4n minus 4. So then a sub n equals 4n minus 10. So for part B, write the value of n for which a sub n equals negative 2. So I just want to know when my answer is negative 2. So I'm just going to use this rule, 4n minus 10. When does that happen? So add 10 to both sides, and I get 8 equals 4n, divide by 4. So n equals 2. So when I'm at the second term, I will get negative 2 out using that rule. All right, graph of an arithmetic sequence. This is something that we'll talk about a little bit in class. Use dots to graph an arithmetic sequence, and it's always linear. Not really anything you need to know for your notes here right now. It just looks like a line that we're used to seeing from Algebra 1. Okay, the sum of a finite arithmetic series. So when it ends, here's how we can find the sum. So this is the sum of n terms. This we know is the first term. This we know is the nth term. Some number that we get to, and this is the number of terms. Right, so find the sum of this series. So we just fill in the pieces. So we want to find the sum of how many terms? We have 6 terms there. So our n value is 6. So we use 6. Our first term is 3. Our last term is 8. And we divide by 2. So we get 6 times 3 plus 8 is 11 over 2. And we get 33. Check it. If you do 8 plus 7 plus 6 plus 5 plus 4 plus 3, you should also get 33 that way as well. All right. Find the sum of the first 25 terms. Here's the problem with this. We don't know the last term. So we have a little bit of work to do before we can get there. We need to know what the 25th term is. To do that, we really need to know the rule. So I'm going to start off with a sub n is equal to, so my first term is 20. My common difference looks to be negative 2. So then if I want to simplify that, I get a sub n is equal to 20 minus 2n plus 2. So I get a sub n equals negative 2n plus 22. There's my rule. But I want to know the 25th term. So the 25th term is where I just plug in 25 instead of n. And so I get negative 2 times 25 plus 22. So a sub 25 is equal to negative 28. Okay, now I can focus on finding the sum of the 25th, or the first 25 terms. So 25 is our number of terms. Our first term is 20. Our 25th term is negative 28. So I'm going to take that and add that up here, and then I divide by 2. So 25 times negative 8 over 2, or 25 times negative 4 is negative 100. So our answer here is negative 100. Okay, here's another problem that involves us working backwards a little bit. It says, find n such that the sum of some number of terms is negative 760. So negative 760 is our answer. It's like our S sub 25 here. We need to know what number n that is. So we're solving for n here. We still know our first term is 20. If we don't know what n is, we don't know our last term. So we currently have 2 unknowns, but we know what a sub n is. We found it up here. So we're going to use that down here. Instead of a sub n, we're going to put negative 2n plus 22. We're going to put that rule in there. So negative 760 equals n times 20 plus negative 2n plus 22 all over 2. From there, we're going to simplify. So I'm going to try to take care of everything inside the parentheses before I do anything else. So negative 760 equals n times, this would be negative 2n plus 42 over 2. Remember, when I divide by 2, I actually divide both things by 2. So negative 760 equals n times negative 2 divided by 2 is just negative 1, or the opposite of n. And then 42 divided by 2 is 21. So then I have, if I want to distribute that n, I get negative 760 equals the opposite of n squared plus 21n. Well, I'm all about keeping n squared positive because we're probably going to have to factor, so I'm going to move everything over to the left. So add n squared and then subtract 21n to put it on the other side. So then I still have minus 760 is equal to 0. So I need 2 numbers that add up to negative 760. Or sorry, that multiply to negative 760 and add to negative 21. Pause the video, take a minute if you want to work through that. I get negative 40 and 19. So n squared minus 40n plus 19n minus 760 is equal to 0. So n times n minus 40 plus 19 times n minus 40 is equal to 0. So n plus 19, n minus 40 is equal to 0. So n equals negative 19 or n equals 40. Well, does it make sense that the term number would be negative if we're counting a number of terms? Not really. So that means that at 40 terms, if we add the first 40 terms together, we will get negative 760 as our answer. Alright guys, that's all I have for you today. If you have questions, come see me in class, or come see me, otherwise I will see you in class. Have a great day.